Welcome to The Explainer. I'm your host, your chief exam strategist, and today we are tearing down the walls of the Cambridge Computer Science examinations. We're going to approach this entirely differently than you're used to. Today, you aren't just a student, you are a top-tier barrister, and you are going to build your exam answers like a watertight legal case. You need irrefutable evidence, a structured argument, and an undeniable conclusion. We are specifically looking at a notoriously brutal topic that shows up constantly in AS and A-Level 9618, mastering hybrid topology. But listen closely, whether you're taking 9618 or building your foundations in syllabus codes 0417, 0478, 0983, 0984, or 2210, the strategy we are unpacking today is universal. Let me set the stage with a real challenge. Imagine a notoriously complex past paper question, the kind of multi-part network diagram question that makes your heart sink. I want to introduce you to two typical candidates. Let's call them Alex and Sam. Now, Alex is a walking textbook. When faced with this hybrid network question, Alex overloads the page with raw computer science facts. I'm talking a massive wall of text about star and bus networks, but absolutely zero critical analysis. The examiner's red pen just slashes through it. Then we have Sam. Sam knows the material, but panics under the clock. Sam rushes, completely misses the specific command word requirements, and writes an answer that solves the wrong problem. Side by side, it's a bloodbath of lost marks. Today, we're going to take you from an Alex or a Sam right to the top of the grade boundaries.
Here is the brief we're working through today. We're going from core theoretical foundations straight through the technical framework, pushing into higher-order critical analysis, dissecting top examiner warnings, and finishing with a completely standardized exam strategy.
All right, let's open up Section 1, Core Theoretical Foundations.
Now, a great barrister always opens their case by defining the parameters for the jury. You have to do the exact same thing for the examiner. A hybrid topology is a complex network structure combining two or more different standard topologies. Think of a massive corporate office using a star bus network. But here is your first major examiner alert. The students who score the highest, the top 1%, they never make assumptions. They explicitly define their terms right at the start of their extended responses. If you look at our student Alex, Alex just jumped straight into talking about data packets without actually defining the network structure first. It's like arguing a legal case without telling the judge what crime was committed. You lose the examiner's confidence immediately. Define before you use every single time. It sets the foundation for your evidence.
Okay, really look at this quote pulled directly from the examiner reports. The assessment framework prioritizes analytical depth over superficial breadth. This is exactly where our students Alex and Sam went wrong, and it brings us to the strategy reveal. Examiners do not care how many random facts you can memorize. They care about how deeply you can analyze a specific scenario. To do this, you need to decode the command words. Words like evaluate, compare, or justify. And to answer them, you must use the PEEL framework. PEEL. Point, evidence, explanation, link. You make your point about the hybrid topology. You provide evidence from the diagram or scenario. You give a detailed explanation of the technical workings. And finally, you link it directly back to the question asked. That is how you build a winning case. Now, before we continue and look at exactly how to apply this framework to get those top marks, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you want these strategies in your feed every week.
Let's keep moving. Section 2, Technical Procedural Framework. Time to put the strategy into practice.
We are entering the transformation phase. We're going to take those red pen marks on Alex and Sam's papers and turn them into green check marks. Look at these 3 steps for handling data interpretation in hybrid network questions. First, extract from binary representations. Second, perform calculations. Third, draw evidence-based conclusions. This is where we implement the computer science success blueprint. Now, I want you to imagine we're giving Alex a chance to rewrite that failed answer live. I'm putting 60 seconds on the clock for Alex to apply the PEEL framework to a multi-step calculation. Instead of just guessing the final IP address subnet, Alex explicitly writes down the extraction of the binary data. That's the point and evidence. Then, Alex shows the exact step-by-step calculation. That's the explanation. Why does this matter? Because examiners use a method mark strategy. They know these multi-step processes are brutal under pressure. Even if Alex messes up the final addition by 1 bit, because the process, the explanation is so clear, the examiner awards almost all the marks. The evidence of the workflow is what wins the case.
Let's look at the programming and practical side, specifically algorithm design for data routing in these hybrid topologies.
Let's look at Sam. Remember, Sam rushed. Sam tried to jump straight to step 2, implementing a solution without actually designing the algorithm or testing it. Absolute disaster. To get top marks, you must follow this evidence chain. Design the algorithms to handle the specific quirks of a star mesh hybrid, implement the solutions logically, test them thoroughly against edge cases, and finally evaluate the overall performance. This isn't just a list, it's a chronological workflow. By writing your extended answers showing how testing informs the evaluation, you are proving to the examiner that you possess a higher-order understanding of network stability. You are demonstrating the Peel framework perfectly. You are linking the test results back to the performance evaluation.
All right, moving into the big leagues now. Section 3, Higher Order Critical Analysis. But first, listen up. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, we are officially kicking off the interactive workshop portion of this explainer. I need you completely focused. This slide is the holy grail of evaluative thinking. Top-tier candidates don't just see one path. They consider multiple solutions. They rigorously analyze trade-offs, like sacrificing initial setup cost for long-term scalability. They openly acknowledge the physical limitations of the hardware, and they justify every single claim with hard, undeniable evidence. This is the exact mindset you need when the command word is evaluate. You are playing the role of an impartial judge weighing the pros and cons of different network infrastructures.
Here is challenge 1 of our workshop, the data scan. I'm putting a virtual 60-second timer on the screen right now. I want you to rapidly scan this complex data table and extract the core trend. Go! Look at the metrics. Time complexity directly equals speed bottlenecks. Space complexity dictates your hardware limits. Edge cases represent extreme parameters that lead to total system failure. What's the trend? The trend is that every single theoretical metric has a brutal, real-world consequence on a hybrid network. If you are writing an exam answer and you only talk about execution duration without explicitly linking it to speed bottlenecks in the specific company's network provided in the prompt, you lose the link part of the PEL framework. The time is up. Did you spot how these metrics act as the exact evidence you need to build your argument? If you want to prove a network will fail, you quote the space complexity limits. That's how a barrister argues.
Section 4. Top Examiner Warnings. This is where we learn from the fatal mistakes of others.
Welcome to Challenge 2, Find the Flaw. I'm going to tell you the top 3 mistakes directly from the principal examiner reports, and you need to think about where you make these errors. Mistake 1. Confusing cause and effect. Mistake 2. Forgetting boundary conditions entirely. Mistake 3. Lacking specific context to the question. Now, imagine a flawed paragraph written by Sam. Sam writes, "The network will have fewer collisions, which means we should install a central switch, making it a good network." I'll give you a second. Where's the flaw? Exactly. It's mistake number 1, but it also heavily features mistake number 3. It lacks all context, and Sam totally reversed the logical flow. You don't get fewer collisions magically, which then leads to buying a switch. You buy and install the switch, the cause, which results in fewer collisions, the effect. Examiners read thousands of papers where candidates get this totally backwards, costing them massive analytical marks.
Let's lock this down with Challenge 3, Speed Writing. We are looking at a clear comparison. The cause is the technical network change or structure implemented. The effect is the resulting performance impact or outcome. I'm giving you 30 seconds right now. In your head, or scribble it down, write one perfect Peel paragraph using this distinction. Point: the company should implement a star-bus hybrid. Evidence: because the scenario states they need centralized control in multiple separate departments. Explanation: installing local switches in each department, the cause, reduces local data collisions, the effect. Link: therefore, this structure directly solves the latency issue mentioned in the prompt. Bam! 30 seconds. That is exactly how you structure a high-scoring, undeniable argument. You clearly separate the technical implementation from the performance outcome, proving to the examiner you fundamentally understand how network architectures actually operate in the real world.
We're in the home stretch now. Section 5, Standardized Exam Strategy. Let's build your final system.
Here's your ultimate cheat sheet recap, the complete computer science answering system. It's a 5-step sequence that guarantees top marks if you follow our 3 golden rules. Step 1, identify the key elements. Step 2, apply relevant principles. Step 3, execute analysis. Step 4, verify results. Step 5, present in format. Now, how do we execute this? By applying the 3 rules. Rule 1, command word decoding. You must know exactly what the question is asking you to do before you write a single word. Rule 2, Peel framework application. Every extended answer must have point, evidence, explanation, and link. And Rule 3, the time management matrix. Don't be like Sam. Don't rush the analysis phase just to write down more useless facts like Alex. Spend the time mapping your evidence, verifying your edge cases, and making sure your final presentation format matches what the examiner actually asked for. Watch your marks potential hit 100% when you stack these strategies together.
Look, exam day is incredibly stressful. Your brain is going to be under immense cognitive load. So use this memory hack. Create a custom, weird, or funny mnemonic using the first letters of the key terms we discussed today for hybrid topology. Terms like extract, calculate, conclude, design, implement, test, evaluate. When you sit down in that exam hall, write your mnemonic at the top of the page. It serves as your personal strategy outline. Active recall techniques like this ensure that even when the adrenaline is pumping, you won't skip a crucial step in your analytical framework. You'll remember to test thoroughly before you evaluate, securing every single method mark available.
As we close this case, I want to leave you with one final provocative question to think about. What is the one boundary condition in your hybrid network design that could cause the entire system to fail? Take everything we've talked about today, the Peel framework, the cause and effect, the edge cases, and go apply it to a real past paper. Now listen up, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at ACEXAMS_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.